All right, in this video, I'm going to be going over just one part of free response number 2 from the 2015 A/B test. So if you need to see the solution, you can Google that. But I'm just going to be going over part B on this one. This one has to do with cross sections, which we learned just recently, a little bit before spring break, but I only spent a day or two on it. This was the concept where we are finding the volume of some object, and cross sections mean that that three-dimensional object, you're cutting it, you're slicing it vertically somehow, and that creates cross sections. And on the AP test, they traditionally have asked that those cross sections are sometimes squares, rectangles, equilateral triangles, etc. And so for this problem, this is just an example of one of those. In 2015, they asked about finding um, the volume of a solid with squares as their cross sections. Okay, so in this problem, it gives you two functions. This was a calculator problem. I've labeled f and g here on the screen, and it's in part B, it's asking that region S is the base of a solid whose cross sections are perpendicular to the x-axis, and those cross sections are squares. Find the volume of the solid. So first off, perpendicular to the x-axis means that if you were to think about this as a really weird shaped loaf of bread, where the base is the shape of this region S right here that I'm highlighting. Okay, that's the base of this shape. And if you're thinking about this loaf of bread, you can kind of think about how bread is baked. They put it in a pan and it rises. And so this region S right here would be the base of the pan that you're pouring the dough into. Okay, so this is what the bottom of the loaf of bread looks like. And after you've baked your bread, you pull it out, the slices that you're cutting on this bread, this problem tells you that those slices have to be perpendicular to the x-axis. Now, perpendicular means going at a 90-degree angle to the x-axis in this case. So that means my slices are being cut this way, like that. So I'm chopping this piece of bread like this. And when I make a chop and I remove what I've chopped and I look at the bread from this side, I should see a square in this problem because it tells me that the cross sections are squares. So I'm going to redraw this picture right here a little bit differently so you can kind of see what it would look like. So there's the top of the base and there's the bottom. I'm trying to draw this three-dimensionally. And each slice is a square. So I'm going to first draw the cut that I'm making, and then I'm going to draw a square coming up out of the page from it. And then the more squares I draw, that's not accurate. Let me draw like this. There we go. So the closer I'm getting towards the ends, the smaller these squares are getting because the distance between the two sides of the pan is getting closer together. So by the end of this, my squares are really close together. And so you can kind of think of this shape looks something like this. Okay, that's just a rough interpretation. I'm sure you can Google and find a better representation, a visual representation of this. But now to figure this out, with calculus, finding the volume of that object, we need to first determine if I'm using a square, the area of one square. So if I made one slice, the area of one slice, you just do side squared. And in this case, one side of one square is the distance between the two graphs here, top minus bottom. And now the top graph is f of x and the bottom graph here is g of x. So we've got f up here and g down here. So to determine one side of a square, you do f minus g, top minus bottom. Okay, and now to determine how far up the bread has risen at each of those slices, it's a square. So the height of it should be the same as the distance between f and g for each of those slices throughout. So you can think of each square as a different size. coming out of this base of the pan. So now to set this up, if I were to just find the area of the base, I would integrate from my two bounds. Now for this problem, it's a calculator problem, so you can find that the first intersection, or the first bound, the lower bound right here, it's some value. We'll just call that x coordinate a. And you want to integrate until, sorry, my screen is in the way. You want to integrate it until this coordinate right here, which is 2, which is given to you in the problem. So you can find a by finding the intersection in your calculator. But whatever that is, you start integrating from there to 2, and we do top minus bottom. So for this problem, it was f of x minus g of x, top minus bottom. Now that gets us the distance just from the top to the bottom, but since I'm finding the area of squares now and adding all of those individual squares up, I want to square that right there, because essentially f minus g is the length of a side. And if I want my cross sections to be squares, I do side squared. And so I'll tack on a dx right here, and you would integrate this guy right here. Okay. Now let's talk about how this would change if it was, for example, a rectangle. So you got the same two graphs, but now it's a rectangle. So this one was a square. Okay, so if it asks that the cross sections are now rectangles, it'll probably tell you, and it should tell you, something else about these rectangles. For example, there's another free response question where they ask the cross sections are rectangles where the height is twice the length of the base. So I'll put that here, that the height of each rectangle is twice the length of the base. It'll tell you that specific information in the problem. And so in this case, the area of a rectangle, one of those slices that you're making, would be the base times the height. Now the base, let's just say we call it b, times the height. Now we just said the height is 2 times the base. So then it would be 2 times b, like that. Base times height, base times 2b. We're just replacing the height with the 2b right here. So then this becomes 2b squared. Okay. And now, so how this problem would change, if it was a rectangle in this type of a situation where the height is 2 times the base, it would still integrate from a to 2, but I would now have f of x minus g of x. Now that distance again is representing the length of the base. And now we just said that the area of one of these rectangles, these slices that I'm making, is 2 times the base squared. So now what I need to do here is put a 2 in front and put a squared outside of f of x minus g of x, and then do dx. And this would give me this new volume as if I were to create the cross sections with rectangles. Okay. And now you can do the same thing for different cross sections. For example, you could do it with a right triangle, you could do it with an equilateral triangle, an isosceles triangle. Each of those cross sections has a different formula that you'll need to figure out in that specific problem. So for a square, it's side squared. For a rectangle, it's base times height and whatever relationship they've given to you between the base and the height. For an equilateral triangle, you can use your geometry rules to figure out what the height is, because the area of a triangle is 1/2 base times height. Just figure out what b and h are in your specific problem. Okay. If you have more questions, please email me. I can guide you to different free response problems that show you different types of cross sections. Okay.